So let's do some practice with those. So I'm going to erase this. I was just trying to get ahead. So the first one is asking us to find the volume and the surface area of a cone. So there's kind of a method to my madness. I always do problems the exact same way. If any of you guys know me, you know that I'm like systematic. I always do stuff the same way. It just makes me feel better. So I always write the formulas down. And I always start with finding capital B, because capital B stands for the area of the base. So regardless of what the shape is, I always need to know the area of the base. So I find that first. I am looking for the base of a circle. That's why that says B, and then it looks like sub-zero, but it's really the base circle. So the base or the area of a circle is pi r squared. My radius is 3. 3 squared is 9. So the area of this circle is 9 pi centimeters squared. Notice that I don't multiply it out by pi. I don't turn it into some decimal. You know, geometry is all about precision and accuracy and being exact. So we just leave things in terms of pi. The volume of the cone is 1/3 times the area of the base, which we are discovered to be 9 pi, times the height of the cone, which is 4. Well, 1/3 of 9 is 3, or sorry, 1/3 of 9 is 3. So I have 3 pi times 4, which is 12 pi. And volume is cubic, so centimeters cubed. The surface area, well, when I look at the surface area of the cone, I need the area of the base, right? That's the pi r squared. But I also need the area of this kind of slanted piece right here. And that's pi times radius times my slant height. So when we talk about slant height is represented by a cursive L, and that is this guy right here. So the surface area is pi times my radius, which is 3, times my slant height, which is 5, plus the area of the base, which I know is 9 pi. Well, 3 times 5 is 15. 15 times pi is 15 pi. 15 pi plus 9 pi is 24 pi. So the surface area of this shape is 24 pi centimeters squared. So now I want to look at the triangular prism. Prisms are named by the shape of their base, and even though it's not sitting on the base, remember that in order for it to be a prism, it has to have two congruent bases, and these are the only two congruent faces or bases, right? So this is a triangular prism. So the first thing I have to do is find the area of the base, and the base happens to be a triangle. So that's what I'm going to do first. So the area of the triangle is 1/2 times 8 times 6, or 24 feet squared. So when I talk about finding the surface area, well, let's do volume first, sorry. When I talk about the volume is just the area of the base times the height, capital B times H. So area of my base right here, this is my B, and then this is my little height of my prism. So 24 times 12 is 288 feet cubed. The part that we need a little bit explaining, for the little bit of explanation maybe, is the surface area. So when we talk about finding the surface area of a prism, remember I said we use 2 times the area of the base. So 2 times the area of the base, which is 24. But I need to know the perimeter of the base. So it's going to be plus the perimeter of the base. And I don't know the perimeter here. I don't know the perimeter because I don't know this measurement right there. This is not given to me. So I have drawn this off to the side. But I know that this is a right triangle because there was a little red square right here. So how am I going to find this measure? Well, hopefully you guys are thinking to yourself, right triangle, let's do Pythagorean theorem. But maybe, just maybe, there are some of you out there that remember Pythagorean triples. Pythagorean triples are integers that exactly make the Pythagorean theorem work, like 3 squared plus 4 squared equals 5 squared. Or, well, I'm not going to tell you a bunch of them, I guess. Like 19, 40, and 41. That's another Pythagorean triple. Or 5, 12, and 13. So those are Pythagorean triples. Obviously, the longest side, or the biggest number, is the hypotenuse. Now, this isn't a 3, 4, 5. This is a 6, 8, 10. Because not only does 3, 4, 5 work, but every multiple of that. So I'm hoping that you guys remember that. So I know that the perimeter is 6 plus 8 plus 10, which is 24, times my height, which is 12. Well, that just happens to be the same thing as it happens to have the same measurement as my volume, and 2 times 24 is 48. So my final answer when I add these together is 336 feet squared. So I am going to redraw this for our answer, 336. So I feel like it is way easier to use the formula 2 times the area of the base plus the perimeter of the base times the height, just because I think it's important for you guys to believe that this formula works. So I remember that this was a measure of 12. So this was 12, this was 8, and this was 6. So if you think about finding the total surface area, remember that the surface area is just the sum of all the faces. That's how you learned that. 6 times 8 is 48, divided by 2, 24. So this face right here has an area of 24. And that means that this face right here also has an area of 24. But then I have this face in the back, which is 6 units tall and 12 units long, and 6 times 12 is 72. But then I have the bottom face, which is 12 units long and 8 units wide, and 8 times 12 is 96. But I also have this top piece right here, which is 10 units by 12 units. 10 times 12 is 120. So if I add them all up, 120 and 96 and 72 and 24 and 24, let's see, this becomes 10, 16, 10, 17 plus 6 is 3. Let's see, sorry, 16, 17, 18, 19, 20, 21, 22, 23. Carry my 2, 3. 336. And what did we get? Way easier to do that than it is to find the area of all of the faces and add that together. Our last example is about a tube. So Mike is creating a mailing tube. Think of it as like maybe a roll of wrapping paper, like the tube that's inside of a wrapping paper. So he's using this to mail posters. The diameter of the base is 3 3/4 inches. So I've drawn my tube and I've marked my diameter. And then the height is 2 2 2/3 feet. I need to find the amount of cardboard to make the tube. I'm just talking about the outside of the tube. I'm not putting caps on it, so there is no base. So the surface area of this tube is just that outer ring, the 2 pi RH. But there are a couple of things. This is given to me as inches and its diameter. So the diameter is 3 3/4 inches, which becomes 15/4 inches. But if I want to find the radius, I have to divide that by 2 or multiply by 1/2. So the radius is 15/8 of an inch. And yeah, you could turn it into decimals if you want, but I'm a fraction girl. And then I have 2 2/3 feet for the height of the tube. 2 2/3 feet is the same thing as 8/3 feet, but I need to turn that into inches. So I take that and I multiply it by 12/1 because there are 12 inches in a foot, and that becomes 32 inches. So my height is 32 inches. I love giving questions, hint, hint, where the units are changed, like this one. So you need to watch for that. So let's plug in what we have. I have 2 times pi times my radius, which is 15/8 times 32. I'm going to write it as 32/1 because I'm going to cross reduce, and that becomes a 4. So I really have 2 times 15 times 4 times pi. Well, 2 times 15 is 30, times 4 is 120 pi inches squared. Now, that's the exact amount. Now, if they asked you to give your answer to the nearest tenth, then you would multiply through by pi. And in geometry, we use the pi button. We do not use the approximation 3.14. You need to use the pi button on your calculator, okay? All right, that's all I have for you. Your homework today, I think it has 18 questions in it. And then tomorrow we're going to do a review in ConnectEd. And then Friday we're going to do an interactive review via Zoom. I'm kind of excited. And our chapter test is going to be on Monday, okay? Good luck.